Today, I'm going to teach you about energy. What are the two types of energy? Does anybody know? There's two types of energy: kinetic and potential. What is kinetic? Kinetic energy. An object in motion has the ability to do work and thus can be said to have energy. The energy of motion is called kinetic energy, from the Greek word kinetikos, meaning motion. And that means this object has no energy. It is not in motion. It is doing no work. As the car rolled down the table, it had kinetic energy because it was in motion. The next energy we will be covering is potential energy. Potential energy is an energy that is associated with forces that depend on the position or configuration of a body. That basically means that it is energy when an object is not in motion. It's the energy that it has the potential to do. The car has 100% potential energy in this position. It has the potential to do energy, but it is not in motion. When you release the potential energy, it becomes kinetic energy. Before we go any further talking about kinetic and potential energy, I'm going to talk about some basics of energy. The work energy theory. Work equals the change in kinetic energy. When an object is put in motion, potential energy turns to kinetic energy and positive work is being done. There are no such things as hot and cold. It is relative to your body temperature. The equation for kinetic energy is as follows, you morons. K, kinetic energy equals 1/2 mass times volume squared. K equals 1/2 mv squared. The equation for potential energy is as follows. U equals mgh. U equals mass times gravity times height. The next important topic is law of conservation of energy. It goes off the basic principle that energy cannot be created or destroyed. The law of conservation of energy is as follows. Ko plus Uo equals Kf plus Ua. K original plus U original equals K final plus U final. The equation can also be 1/2 mv squared plus mgh equals 1/2 mv squared plus mgh. 1/2 mv squared stands for kinetic, and mgh stands for potential. This is the original, final. The book has potential energy, kinetic energy as it falls, and potential energy when it hits the ground and stops moving. Energy cannot be created or destroyed. In this problem, at the top of the roller coaster hill, there was 100% potential energy and 0% kinetic energy. As the roller coaster goes down the hill, there's 50% potential energy and 50% kinetic energy right in the middle. At the bottom of the hill, there's 100% kinetic energy and the roller coaster has reached its maximum speed. As it goes back up the hill, the same thing occurs. 50% right in the middle, and back to 100% potential energy, 0% kinetic energy. It does not matter if the height's 10 meters, 7 meters, or 1 meter. That same rule applies. Let's do a practice problem.
If the mass is 2 kilograms and the velocity is 3 meters per second, find kinetic energy on the first slope. If the height is 10 meters, find potential energy on the first slope. Energy is measured in joules. So in this problem, you take 2 times 9.8 times 10 to find potential energy, which is 196 joules. Kinetic energy equals 1/2 mass times velocity squared. So in this problem, you take 1/2 times 2 times 3 squared, which equals 9 joules of kinetic energy. At this point, there is 100% potential energy, which is 196 joules. As soon as the roller coaster takes off, the velocity is 3 meters per second, equaling out to 9 joules of kinetic energy. The maximum amount of energy in this problem is 196 joules because energy cannot be created nor destroyed.
This object has potential energy when lifted. I'm exerting work on this object, and that is calories. Calories come from my food, which gets its nutrients from the sun.
You get calories from meat.
The sun powers everything!
Sun!
The sun!
The sun!
The sun.
The sun! The sun!
The sun!
A skier glides on a frictionless hill of 100 meters, then ascends to another hill 90 meters. What is the skier's speed at point B given that the skier's weight is 50 kilograms and the skier's speed at point A is 5 meters per second? I started this off by plugging in all of my variables into the equation and then just solving it algebraically, and then I got 7.43 as my velocity at point B.